Hello, welcome. This is Austin from Tclassified.com. Today I'm going to be working on deep learning technique used in classifying flow patterns. That's what I'm going to be looking at today. Deep learning technique used in classifying flow patterns. So the project is actually deep learning as a tool to predict flow patterns in two-phase flow. So we're going to be looking at using Colab to solve this problem, using TensorFlow and using Keras and other machine learning algorithms. So the term flow pattern is actually the spatial distribution of the phases which occur during gas liquid flow in pipes. Now we are going to be able to classify flows into things like wavy flow, stratified flow and the rest. So we're going to be using a deep learning technique, and I'm actually using Colab. Colab is an app in Google Drive that you can use to write machine learning or deep learning algorithms. So this is my Colab that I just opened that I'm going to be using for this. The name of this is PRGman. I'll drop a link in the description part to my GitHub where you can see the full code. So first of all, what I did was to import all the necessary make the necessary imports for this. I imported TensorFlow as TF, NumPy as MP, Pandas as PD, Seaborn as SNS, Matplotlib as PLT. So after making the imports, I now have to bring in my data. So this is the data I'm using. This data, I actually prepared this data by myself. The features which are going to be used for these predictions are the superficial velocity for gas, the gas superficial velocity, and the liquid superficial velocity. So that these are their values. I actually got these values from the Docker graph. I looked at the graph, and from the graph I was able to put this data together. Now these are the flow patterns that we are classifying to. So considering the superficial velocity, gas and liquid, we can classify a flow to be stratified, wave, annular flow, slug flow, bubble flow, or dispersed. So that is what we are looking at. So getting back to my Colab, I now have to import this data that I have shown. This is my very data. I'm going to import it to Colab so that we can start the training and testing and every other thing. So, and that is what this code is for. From Google Colab, import file. This is how you import files in Google Colab. So you click here and choose the file. The name of the file is my data. So I'm able to import this file. Then when I do import IO and DF, it also PD read CSV. This is how you use Pandas to read out CSV files, because I actually saved this my file. This is my Excel file. Immediately after working on it, I hit on the save as, then save as workbook. Then I came to this save type and I picked CSV. That is how you save to CSV. So this is CSV cover delimited. That's how I save this as CSV file. So I'm going to go to here and import it. So that's the code for importing it. Then here I'm able to read it into my Pandas data frame, and that is why you can see it like this. You can see that this is the same data that you're seeing in Excel. Now it's now in my Colab. This superficial velocity gas and that of liquid and flow pattern classifications into various distance. So after importing it and displaying the data frame, I'm able to use Seaborn to make a plot by using this code. This is the code. First of all, I was able to classify my flow patterns to read my data. I know that out of the 120 data that I have, 20 of them are stratified, 20 are bubble, 20 are wave, slug, annular and dispersed. I did this in order to know that I'm not doing the wrong I'm not picking out the wrong data points. Then here I'm able to plot this data into graphs. Then using this other code, I'm able to split the data into training sets and testing sets. So I'm using 2% for test and the rest of the 80% for training. So this is where I did that. Then now I built the model. So using dense model for the first input layer, because I'm having only two inputs, superficial velocity gas and superficial velocity liquid. Then using ReLU as my activation function, This is the first layer. Then the second layer and the third layer, I used activation function as stand hedge for the both of them. Then my final layer, I use activation function sort marks. I use sort marks because if you want to classify something that is not 1 or 2, you use sort marks because it reads probability from 0 to 1, so it can actually read out what I want. Adibin is just two classes. I'm going to use sigmoid function, so I'm using sort mark for search. Then I'm using Adam as my optimizer and categorical cross entropy as my entropy or loss function. Then my metrics, the metrics I'm calculating is accuracy. So I'm able to put out this summary, which can also be put in graphical form. This summary, this is the code I use in putting it, model.summary. Then to put it in this form, I use this code to put it in this form, to plot it in PNG format. Then also use this as well to do the dot model to dot and plot it out. Then I use model.fit x train y train epochs 100 in order for me to train my model. So after training my model, I'm able to do the predictions. So using this, I'm able to use argmax in order to start predicting. Then I'm able to feed in these arrays for my testing. Then after that, I can now calculate my accuracy from the predicted value using this code and put this together. So from that, I can now make a sample prediction of these points, 400 and 0.1, all these points. So after making this sample prediction with this code, in order to predict whether it's stratified, wave, annular, slug, bubble, or dispersed, I'm able to get these various predictions. So this is actually part of my thesis. This is my first run of training using different method, not actually utilizing TensorFlow in details. So I'm using this as experimental to start off my thesis. In subsequent one, I'm going to use TensorFlow in details in order to make better prediction. Please, the code to this, I will link this code to my GitHub repository so that you can always go there and get this code. This is an example of using application of machine learning and deep learning in chemical engineering. Please, if you like this video, hit the subscribe button. If you have any questions and concerns, drop them in the comment section of this. Thank you. God bless you.